Hello viewers, in today's class we are going to discuss one important and conceptual problem from definite integration, right? So here we have to evaluate this integral where our integrand involves the signum function, the absolute value function and the greatest integer function, right? So here we have the integral from -1 to 1, greatest integer of signum x minus mod of x, right? So in order to evaluate this integral, we have to first make use of the definition of signum function and the absolute value function, right? So before applying the definition of signum function and the mod function, what we will do, we'll take a close look at these two limits of integration, that is -1 and 1, and we see that when we have -1 and 1, right? Here we have -1 and here we have 1, right? And between -1 and 1 we have the integer that is x is equal to 0, right? So what we will do, we'll first take this integral as I, and then we'll split this integral as a sum of two integrals, right? So the first one is from -1 to 0 and the second one is from 0 to 1, right? So this breaking of integrals is due to, or it is significant with the definition of signum function and the mod function. So now let us first take the definition of signum function, right? So we know that the signum of x is equal to +1, that is signum of x will take +1 value whenever x is greater than 0, and signum of x is equal to 0 whenever x is equal to 0, and signum of x will take the value -1 when x is less than 0, right? So this is the definition of signum function, and let us now take the definition of mod x, right? So mod x is defined like this, that is mod x is equal to plus x whenever x is greater than 0, mod x is equal to 0 whenever x is equal to 0, and mod x is equal to minus x whenever x is less than 0, right? So now let us come to our integral. Now here we have I, and now we will split this integral as a sum of two integrals, that is I1 and I2, right? So I1 can be written as -1 to 0, and we have greatest integer of signum of x minus mod x, and then we have I2 from 0 to 1 and greatest integer of signum of x and mod of x, and here we have dx, right? So now we have the sum of two integrals, right? Now let us take these two integrals one by one. So let us first take I1, right? See, when we have I1, the limits of integration are from -1 to 0, right? So when we go from -1 to 0, it means all the values of x are less than 0, right? So what we will do, we'll take the signum of x is equal to -1, right? Because x is less than 0. So whenever x is less than 0, signum of x is equal to -1. So when we go from -1 to 0, then obviously all the values of x lying between -1 and 0, they are all less than 0. So here signum of x will be equal to -1, right? Okay, and here in case of I2, when we go from 0 to 1, that is from 0 to 1, obviously all the values of x which lie between 0 and 1 are greater than 0, right? So in this case signum of x will be taken as +1, right? Because x is greater than 0. So here we'll have +1, right? Okay, now let us come to the mod function. See, here we have -1 to 0 in I1. So obviously all the values of x are less than 0, right? So when x is less than 0, then mod of x is equal to negative x. So here we'll have minus x, right? Because x is less than 0 in the interval -1 to 0. Similarly, here when we have x lying between 0 and 1, then mod x is obviously equal to plus x, because x is greater than 0 in the interval 0 to 1. So mod x is equal to plus x, right? So once we have discussed all these things, we can now rewrite these two integrals as -1 to 0. We have greatest integer of, here we have -1, then we have minus, and we have here minus x, right? And here we have 0 to 1, greatest integer of, here we have signum x is equal to +1, and here we have plus x, right? Okay, so now we have these two integrals. We can simplify it further. -1 to 0, here we have -1 plus x, and then we have 0 to 1, and here we have 1 minus x, right? So now we have to evaluate these two integrals. So now viewers, in order to evaluate these two integrals, here we have to make use of the definition of greatest integer function, right? So let us take this integral first. So here we see that x, it lies between -1 and 0, right? See, the limits of integration are from -1 to 0. So x lies between -1 and 0, and see here inside this greatest integer function symbol we have -1 plus x, right? So we have to decide the value of greatest integer of -1 plus x, right? So what we will do now, we'll add -1 throughout this inequality. So what we will get, -1 -1, here we have x -1, and then we have 0 minus 1. So what we have done here, we have adding, or we are adding -1 throughout this inequality. So we have -2, this is x -1, and this is -1, right? So we see x -1 lies between -2 and -1. So by the definition of greatest integer function, the value of greatest integer of x -1 should be equal to -2, right? Okay, so now let us take this integral. Now here we see that x varies from 0 to 1, right? So when x lies between 0 and 1, then we have to decide the value of greatest integer of 1 minus x, right? So in order to get the value of greatest integer of 1 minus x, first we have to get the value of or get the expression for 1 minus x, right? So what we will do, we'll multiply this inequality throughout by -1. So we'll get 0. The direction of the inequalities will get reversed. So here we have -x, and here we have -1, right? So this can also be written as -1 minus x and 0, right? So now see, here we have the number 1. So what we will do, we'll add 1 throughout this inequality. So what we'll get, -1 plus 1, here we have 1 minus x, and here we have 0 plus 1. So we have 0, then we have 1 minus x, and here we have 1, right? So we see that 1 minus x lies between 0 and 1. So therefore the greatest integer of 1 minus x should be equal to 0, right? So the value of greatest integer of 1 minus x when x lies between 0 and 1 is 0. So here we have 0. So this integral disappears here, and when x lies between -1 and 0, the value of this expression is equal to -2, right? So now this integral is 0. So we have -1 to 0, and here we have -2 dx, and this integral is 0, right? So now we can simply evaluate this integral. So we have minus 2 outside the integral, we have minus 1 to 0 dx, and we have minus 2, and integral of dx is x. Limits are from minus 1 to 0, so we have minus 2, 0 minus minus 1, and then we have minus 2 times plus 1, and that is equal to minus 2, right? So the value of this integral is equal to minus 2, right? So viewers, this is how we solve this type of problems.